This is lesson 412, Tangents, Secants, and Chords, part 2. The objectives in this lesson is you will define and identify tangent segments, secant segments, and external secant segments. You will also use theorems about tangents, secants, and chords to find missing segment links. We got a couple of key terms in this lesson. The external secant segment is a secant segment that lies in the exterior of a circle with one of its endpoints on the circle. Then a secant segment is a segment of a secant with at least one of its endpoints on the circle. Now we need to remember what we've learned in previous lessons is that we can have two tangents, a tangent and a secant, or two secants. And we're going to be going over these as well in this lesson. So we can recall that a tangent segment is a segment of a tangent line with one of its endpoints at the point of tangency. So in the figure, AP and BP are both examples of tangent segments. And we've also learned in previous lessons how to calculate the chord lengths. And let me get my highlighter turned on here. Well, I gotta use a different color besides yellow. Okay, that'll be okay. So just helping you see how this plays out. Here's AE, and I'm highlighting this AE segment. That's not showing up too well. Let me get another color. I bet that won't show up very well either. Let me see. Let me highlight that. There, that's a little better. Kind of makes it too dark. So here's AE right here. And here's the segment AE. Okay, and then I just want you to pay attention to exactly what it is that you're multiplying together. So then here's segment EB. I'm doing this in a purple highlighter. So there's the two segments that you're taking one segment with its two parts and multiplying it together. So I just wanted to help you be able to visualize exactly what it was that's being multiplied. Okay. Now with the secant segment, it says a secant segment is a segment of a secant line with at least one of its endpoints on the circle. So segment AB is a secant segment with at least one of its endpoints on the circle. And you can see here that that's its endpoint and it's on the circle. The other point is outside the circle. Okay, now we have a secant segment. It says secant AB, or no, I'm sorry, segment AB and segment BC are both secant segments. Okay, although they're just one, they can be considered one segment by going from A to C. Whenever you break it up, each one of those is considered a secant segment. Both segments have at least one of their endpoints on the circle. Okay, so if you're looking at BC, B is going to be your endpoint. If you're looking at AB, or even if you went to AC, you've got an endpoint right there with point A. Okay, so we usually refer to segment AB as a chord, and you'll see here that I highlighted it in red. When we see a segment like that, we think of it as a chord. We don't think of it as a secant. Now BC is what I've highlighted up here in blue, and we consider BC an external secant segment. An external secant segment lies in the exterior of a circle and has one endpoint on the circle. So notice all that I've highlighted in blue here is outside the circle. So that's what makes it an external secant segment. Okay, so when you have two secant segments that intersect, like in the figure above where they intersect at point C, you're gonna, other than the points changing names, you can always calculate the length of the segments by using this formula. And what you see here, if you look at segment AC, it's the whole segment. And if you look at segment BC, that's the external secant segment. And again, if you look at EC, that's the whole secant. And if you look at DC, it's the portion that's outside the circle, which is your external secant segment. Anyway, you multiply those together, just kind of like we did with the chords, and they're going to be equal to each other. And the same thing happens with a tangent and secant segment. It says, if we're looking at this picture and we think of the tangent segment AC as a secant segment in which the whole segment and the outside part are the same. That sounds kind of confusing. Then you can apply the previous theorem by replacing BC with AC. So if you look at the previous theorem, look right here. We've taken this segment right here, this ABC, and what we've done, and I can't do it on this PowerPoint, but what they're doing is they're taking point A and they're moving it right up here, okay, to where the secant becomes a tangent. So let's look. See how they moved it up? And so where it says AC now, the B's just disappeared. It's gone. So the point is here that, alright, so if you look, remember on the other, we had whole times outside. Well, AC is the whole, and the outside is also AC, so that's why that works. Well, when you take those two variables, AC, and you multiply them together, you're actually squaring them. So that's why we say AC squared equals EC multiplied by DC. So you're going to take the whole squared equals the whole multiplied by the outside. Okay, let's do some practice problems. It says, find the length of DC if AC equals 12, BC is 6 centimeters, and EC is 18 centimeters. So AC, and it's kind of hard to label these because there's points in the middle, but I'll do it like that. And then BC is 6, and then EC right there is going to be 18. So remember, and you don't have to write this down all the time because it's a lot to write. You've got the whole times the outside equals, and I'm already going to run out of room, whole, what I'll do is I'll abbreviate outside. So the whole in this example is going to be AC, the outside is going to be BC, the whole of the other secant is EC, the outside is DC. So now I'm going to substitute with the values they gave me, 12, BC is 6, EC is 18, and I'm calculating the length of DC. So 12 times 6 is going to give me 72. 18 times DC will just be 18 DC. Then you're going to divide both sides by 18. 72 divided by 18 is 4. Those two reduce to 1, so I'm left with 4 equals DC. So the length of DC equals 4 centimeters. Okay, now it says find the length of EC if AC equals 8 centimeters, BC is x minus 1 centimeters, and DC is 2 centimeters. So there again, and I'm going to abbreviate, you've got the whole, the outside equals the whole multiplied by the outside. So my whole segment can be AC, the outside will be BC, the whole is EC, the outside is DC. So now I'm going to plug in the information they gave me. They told me AC was 8. They told me BC was x minus 1. I do not know what EC is. That's what I'm calculating. They told me DC was 2. So now I've got to distribute that 8 to everything in the parentheses. So I have 8x minus 8 equals 2 EC. They left out some that says find the length of EC. Either I left something out or they left something out, because I know that EC, this right here, is supposed to be 3x. Okay, I went in and fixed that. Okay, I know that EC is 3/6, so I substituted EC with 3x, and then 3x times 2 is going to give me 6x. So what I'm going to do now is I'm going to subtract 6x from both sides, because I want to get my variables on one side and my numbers on the other, and 6x minus 6x is going to give me 0. So let me rewrite that up here. 2x minus 8 equals 0, so I'm going to add 8 to both sides. So 2x equals 8, divide both sides by 2. X is going to equal 4. Well, they wanted to find out what EC was, and it's not in the problem, but I know EC equals 3x. So I'm going to replace x with 4. So EC is going to equal 12 centimeters. Okay, a tangent and a secant. Now remember, on this one, you've got the whole squared, that's going to be your tangent, and then over on the secant side, you're going to have the whole times the outside. So, okay, my whole for AB is what I'm looking for. I don't know that. Okay, that's what I'm trying to find the length of. They told me that DB is this whole thing right here equals 27 inches, and that CB right here equals 3. So I don't know what the whole is, but I'm going to go ahead. It's AB squared. The whole here is 27. The outside is 3. So I have AB squared equals 27 times 3, which is 81. I'm going to get the square root of both sides. So that's going to leave me with AB equals 9. And that's going to be in inches. So that's all you have to do. Let's do one more of these tangent and secants. Remember, here you've got the whole world in your hands. It's me singing a little tune. Every time I say the word whole, I want to say that. Okay, because then it made me forget what I was doing. Okay, so the whole in this one, we're still dealing with the same letters. My whole is DB. My outside is going to be CB. So let's look, oh, that's squared. Let's look and see what they gave us. They said AB is 10, and that's squared. DB is 20, and we're trying to find CB. So 10 squared is 100. Didn't have anything to simplify on the right side. Now I'm going to divide both sides by 20. 100 divided by 20 is 5. So CB is equaling 5 centimeters. Oops. Okay, I didn't miss anything. Okay, in this lesson we learned a secant segment is a segment of a secant that has at least one of its endpoints on the circle. An external secant segment is a secant segment that lies in the exterior of a circle with one of its endpoints on the circle. When two secant segments intersect in the exterior of a circle, the lengths of the secant segments and external secant segments are related by this formula, which is the whole multiplied by the outside equals the whole multiplied by the outside. When a tangent and a secant segment intersect at the exterior, the lengths of the tangent and secant segment and external secant segment are related by this formula, where you have the whole squared equals the whole multiplied by the outside. And what you just have to remember with this is that the whole squared is your tangent, and then all this is your secant. And if you wanted to, we could even say, oh, that wasn't good, external secant. Okay, so when you're finished watching this video, of course, you need to go through and read the LMS lesson on tangents, secants, and chords and complete the student guide. Read through the book and see if you can add some more notes if needed, because remember, you get to use your notes on your test. And complete the following problems in the problem set, which are 6, 9, and 11. And then after you finish that, contact me or attend TOGA if you have any questions before you work on the 412 quiz. And again, make any note of general questions you may have when you attend CC. And please give me your course and section number with all communications so I can help you faster. And that's going to be it for lesson 412. Thanks for listening.